How small assumptions create huge consequences. At the beginning, the assumption feels harmless, almost invisible. A tiny choice made quickly because it seems obvious, reasonable, and not worth questioning, until the effects quietly compound and reshape outcomes far beyond what anyone intended. What looks insignificant in isolation becomes decisive over time, not through drama, but through repetition. To understand why this matters today, we need to look at how systems are actually built. No model starts complete. Every equation, rule, or policy begins with assumptions that simplify reality just enough to make progress possible. They save time. They reduce complexity. They make problems solvable. At first, these shortcuts feel efficient. The system works. Predictions look accurate. Results align with expectation. Confidence grows, not because the assumptions are correct, but because their consequences have not appeared yet. But assumptions do not stay small. They get reused. They get embedded. They become invisible defaults. And once a system scales, those defaults quietly shape everything that follows. Mathematics reveals this effect mercilessly. A slight bias in an equation skews results consistently. A minor constraint redirects entire solution spaces. An overlooked variable grows dominant as conditions change. Nothing explodes. Everything drifts. This drift is dangerous because it feels natural. Outcomes still make sense. Errors appear reasonable. The system does exactly what was told to do. The problem is what was told. In complex environments, assumptions act like lenses. They do not remove information. They bend it. What fits the lens becomes obvious. What does not fit disappears. The most unsettling part is timing. By the time consequences become visible, the assumptions feel untouchable. They are baked into infrastructure, into training, into belief. Changing them feels like starting over. The story of small assumptions is not about mistakes. It is about momentum. Once a system moves in a direction, even slightly, mathematics ensures it keeps going. And that is why the smallest assumptions, the ones nobody remembers choosing, often end up shaping outcomes no one ever intended. As systems grow, these assumptions stop being questioned and start being trusted, not because they were ever proven true, but because everything built on top of them appears to function well enough to justify their existence. Success becomes evidence. Stability becomes validation. And the original simplification quietly hardens into perceived truth. Mathematics shows how this happens. When an assumption is slightly wrong but consistently applied, its effects compound rather than cancel. Errors do not average out. They align. Each decision reinforces the same direction. Deviation becomes structure. This is why early models feel accurate and later ones feel distorted. Initial conditions dominate. Small biases influence pathways. Alternative outcomes disappear not because they are impossible, but because the system no longer points toward them. Choice narrows without anyone noticing. In predictive systems, this is especially dangerous. Forecast-trained decisions. Decisions shape behavior. Behavior feeds back into data. The assumption becomes self-fulfilling. What began as simplification turns into destiny. Institutions fall into this trap easily. Policies assume certain behaviors. Metrics assume certain values. Algorithms assume certain priorities. When reality disagrees, it is labeled anomalous rather than informative. This creates brittleness. Systems look confident, but adapt poorly. They handle expected cases beautifully. They fail catastrophically when conditions shift. The assumption was never wrong enough to trigger alarm, until it was. Emotionally, this is hard to accept. Admitting a foundational assumption is flawed feels like admitting wasted effort. Resistance forms. Defensiveness grows. Change slows. Mathematics offers no sympathy here. It does not care when an assumption was made, only how often it is used. Repetition gives weight. Scale gives power. The most dangerous assumptions are not extreme. They are reasonable. They feel obvious. They survive because they do not fail immediately. And that is what makes their consequences so large. By the time the cost is visible, the system is already committed. This is where the conflict becomes unavoidable, because once assumptions harden into structure, correcting them no longer feels like adjustment. It feels like threat, not outcomes, but to identity, authority, and the legitimacy of everything built so far. The system stops asking whether the assumption is true and starts defending why it must remain untouched. Mathematically, this is predictable. The deeper an assumption is embedded, the more costly it becomes to remove. Dependencies multiply. Processes align around it. Entire chains of logic collapse if it is questioned. The system chooses stability over accuracy. This creates a dangerous asymmetry. Early assumptions require little evidence. Late corrections require overwhelming proof. The burden of justification flips. What was once optional becomes sacred. Feedback loops accelerate the problem. Data generated under the assumption reinforces it. Outcomes shaped by the model validate the model. The system appears correct because it trained reality to behave accordingly. Dissent looks like error. Anomalies are ignored. This is how blind spots grow, not from ignorance, but from success. The system works well enough to avoid scrutiny until conditions change. When reality shifts, the consequences surface abruptly. Predictions fail. Outcomes surprise. Damage spreads faster than explanation. The assumption is finally visible, but removing it now carries enormous cost. Emotionally, this moment is explosive. Blame replaces analysis. External shocks are accused. The idea that the foundation itself is flawed feels unbearable. It threatens careers, reputations, and narratives of competence. Mathematics is indifferent to this discomfort. It traces the path cleanly. Small assumption, repeated use, compounding effect, large consequence. The conflict is not between good and bad models. It is between adaptable systems and rigid ones, between those willing to revisit assumptions and those who protect them at all costs. And as complexity increases, this choice becomes decisive, because systems that cannot question their smallest assumptions eventually face their largest failures. The climax of this story is not collapse, but recognition, because once the role of assumptions becomes visible, the illusion of inevitability dissolves and responsibility returns to designers of systems rather than the systems themselves. What looked like fate is revealed as accumulation. What felt unavoidable is exposed as choice repeated. The resolution lies in humility. Assumptions must be treated as provisional, not permanent. They require regular stress testing. They must be surfaced, not hidden. Questioning them must be rewarded, not punished. Mathematics offers a simple discipline. Change inputs deliberately. Observe sensitivity. Monitor drift. Small adjustments early prevent catastrophic corrections later. Flexibility preserves stability. Systems that survive complexity share this trait. They expect error. They anticipate change. They design for revision. Assumptions are documented, revisited, and challenged continuously. This mindset reshapes accountability. Failures are not blamed on randomness alone. They are traced back to choices. Learning replaces denial. Adaptation replaces defense. The lesson extends beyond mathematics. Organizations, technologies, beliefs, even personal decisions are shaped by invisible assumptions. Making them visible restores agency. Small assumptions do not doom systems. Unexamined assumptions do. The danger is not simplification, but forgetting that simplification ever occurred. Once this is understood, complexity becomes navigable, change becomes manageable, and growth no longer requires collapse. Sometimes the smallest shift in perspective becomes the beginning of a new future. How